In section 7.7, we discussed the separation of source coding and channel coding. Consider transmitting an information source with entropy rate H reliably through a DMC with capacity C. We claim that if H is strictly less than C, this can be achieved asymptotically by separating source and channel coding without using feedback. Consider the communication system at the bottom. In this communication system, the source message U is encoded by the source encoder into an index W. This index W is then used as the input for the channel encoder. From the channel encoder's point of view, this index W is actually a message to be transmitted. The channel encoder then encodes W into a sequence X to be transmitted through a channel PY given X. The sequence Y is received at the output of the channel, and based on this received sequence Y, the channel decoder makes an estimate W hat of the transmitted message W. Then W hat is used as the input for the source decoder, and from the point of view of the source decoder, W hat is an estimate of the index W that is output by the source encoder. And based on W hat, the source decoder estimates the source message U as U hat. Specifically, this is how it works. Since H is strictly less than C, we can choose real numbers Rs and Rc, where Rs stands for the rate of the source code, and Rc stands for the rate of the channel code, such that H is strictly less than Rs, Rs is strictly less than Rc, and Rc is strictly less than C. This is illustrated in the figure as follows. The source message U, which has entropy H, is the input to the source encoder, which has rate Rs. The source encoder outputs W, which is used as the input to the channel encoder, whose rate is equal to Rc, where Rc is strictly greater than Rs. This means that the message set of the channel code is larger than the index set of the source code, which is obviously necessary. The channel encoder then outputs a sequence X, which is transmitted through the channel PY given X with capacity C to obtain the received sequence Y. Then the channel decoder decodes the received sequence Y into W hat at rate Rc. The source decoder then decodes W hat into U hat at rate Rs, where U hat hopefully is almost the same as U and has entropy rate essentially equal to H. In this chain of inequalities, the inequality Rc strictly less than C guarantees the existence of a channel code which can decode W correctly with high probability. And the inequality H strictly less than Rs guarantees the existence of a source code that can decode U correctly with high probability, provided that W is equal to W hat. With such a pair of source code and channel code, the overall probability of error can be made arbitrarily small asymptotically. That is, when the block length n goes to infinity. It can be shown that even with complete feedback, reliable communication is impossible if the entropy rate H is strictly greater than C, the channel capacity. The techniques involved are very similar to the techniques that we have used for proving that feedback does not improve the capacity of a discrete memoryless channel. Please see the textbook for the details. The separation theorem for source and channel coding has the following engineering implications. First of all, asymptotic optimality can be achieved by separating source coding and channel coding. Then the source code and the channel code can be designed separately without losing asymptotic optimality. and we only need to change the source code for different information sources, and only need to change the channel code for different channels. Note that the separation theorem applies in the asymptotic sense. For finite block length, the probability of error generally can be reduced by using joint source channel coding. That is, instead of doing source coding and channel coding separately, we do source coding and channel coding together.